Yes, welcome back. I have rebooted my computer. Now the auto reading should work again. And I did download a fresh copy of Rudolf Diesel, the inventor of the diesel engine. And I scroll up to there, so let's read from there, but I need some juice. It's 10 seconds. Now the auto reading should work. Read loud, activate voice. We have to close this. Read to the end of documents.
Over 900 examples are produced. Its rated takeoff power is 645 kilowatt. 102. 1933. General Motors uses its new Roots blown unit-injected two-stroke Winton 201 a diesel engine to power its automotive assembly exhibit at the Chicago World's Fair, A Century of Progress. 103. The engine is offered in several versions ranging from 600 to 900 HP, 447 671 kilowatts. 104. 1934. The Budd Company builds the first diesel-electric passenger train in the U.S., the Pioneer's FA 9900, using a Winton engine. 103. 1935. The Citroën Rosalie is fitted with an early swirl chamber-injected diesel engine for testing purposes. 105. Daimler-Benz starts manufacturing the Mercedes-Benz OM 138, first mass-produced diesel engine for passenger cars, and one of the few marketable passenger car diesel engines of its time. It is rated 45 PS, 33 kilowatts. 106. 1936, March the 4th. The airship LZ-129 Hindenburg, the biggest aircraft ever made, takes off for the first time. She is powered by four V16 Daimler-Benz LOF6 diesel engines, rated 1,200 PS, 883 kilowatts, each. 107. 1936, manufacture of the first mass-produced passenger car with a diesel engine, Mercedes-Benz 260D, begins. 101. 1937, Konstantin Fyodorovich Chelpan develops the V2 diesel engine, later used in the Soviet T-34 tanks, widely regarded as the best tank chassis of World War II. 108. 1938, General Motors forms the GM Diesel division, later to become Detroit Diesel, and introduces the Series 71 inline high-speed medium-horsepower two-stroke engine, suitable for road vehicles and marine use. 109. 1940s. 1946, Plessy Cummins obtains a patent on a fuel-feeding and injection apparatus for oil-burning engines that incorporates separate components for generating injection pressure and injection timing. 110. 1946, Klockner-Humboldt-Deutz, KHD, introduces an air-cooled mass-production diesel engine to the market. 111. 1950s. Piston of an MAN M system centrosphere combustion chamber type E diesel engine, 4VD145/12-1 SRW, 1950s. KHD becomes the air-cooled diesel engine a global market leader. 112. 1951. J. Siegfried Murer obtains a patent on the M system, a design that incorporates a central sphere air combustion chamber in the piston. DBP 865,683. 113. 1953, first mass-produced swirl chamber injected passenger car diesel engine. Borgwood /Fiat. 82. 1954, Daimler-Benz introduces the Mercedes-Benz OM312, a 4.6-litre straight-six series production industrial diesel engine with a turbocharger, rated 115 PS, 85 kilowatts. It proves to be unreliable. 114. 1954, Volvo produces a small batch series of 200 units of a turbocharged version of the TD96 engine. This 9.6-litre engine is rated 136 kilowatt. 115. 1955, turbocharging for MAN 2-stroke marine diesel engines becomes standard. 97. 1959, the Peugeot 403 becomes the first mass-produced passenger sedan /saloon manufactured outside West Germany to be offered with a diesel engine option. 116. 1960s, Mercedes-Benz OM352, one of the first direct-injected Mercedes-Benz diesel engines. It was introduced in 1963, but mass production only started in summer 1964. 117. 1964, summer. Daimler-Benz switches from pre-combustion chamber injection to helix-controller direct injection. 118. 113. 1962-65, a diesel compression braking system eventually to be manufactured by the Jacobs Manufacturing Company and nicknamed the Jake Brake, is invented and patented by Plessy Cummins. 119. 1970s. 1972, KHD introduces the AD system, All-Stoff-Dioktinspritzung, any fuel direct injection, for its diesel engines. AD diesels can operate on virtually any kind of liquid fuel, but they are fitted with an auxiliary spark plug that fires if the ignition quality of the fuel is too low. 120. 1976, development of the common rail injection begins at the F Zurich. 121. 1976, the Volkswagen Golf becomes the first compact passenger sedan /saloon to be offered with a diesel engine option. 122. 123. 1978, Daimler-Benz produces the first passenger car diesel engine with a turbocharger, Mercedes-Benz OM617. 124. 1979, first prototype of a low-speed 2-stroke crosshead engine with common rail injection. 125. 1980s, BMW E28524TD, the first mass-produced passenger car with an electronically controlled injection pump. 1981/82, Uniflow scavenging for 2-stroke Mariner diesel engines becomes standard. 126. 1985, December, road testing of a common rail injection system for lorries using a modified 6VD12 5/12 GRF engine in an IFAW50 takes place. 127. 1986, the BMW E28524TD is the world's first passenger car equipped with an electronically controlled injection pump, developed by Bosch. 82. 128. 1987, Daimler-Benz introduces the electronically controlled injection pump for lorry diesel engines. 82. 1988, the Fiat Croma becomes the first mass-produced passenger car in the world to have a direct injected diesel engine. 82. 1989, the Audi 100 is the first passenger car in the world with a turbocharged, direct injected, and electronically controlled diesel engine. 82. 1990s. 1992. The 1st of July. The Euro 1 emission standard comes into effect. 129. 1993. First passenger car diesel engine with 4 valves per cylinder. The Mercedes-Benz M604. 124. 1994. Unit injector system by Bosch for lorry diesel engines. 130. 1996. First diesel engine with direct injection and 4 valves per cylinder, used in the Opel Vectra. 131. 82. 1996. First radial piston distributor injection pump by Bosch. 130. 1997. First mass-produced common rail diesel engine for a passenger car, the Fiat 1.9 JTD. 82. 124. 1998. BMW wins the 24 Hours Nürburgring race with a modified BMW E36. The car, called 320d, is powered by a 2-liter, straight-4 diesel engine with direct injection and a helix-controlled distributor injection pump, Bosch VP44, producing 180 kilowatts. The fuel consumption is 23 L/100 km, only half the fuel consumption of a similar auto-powered car. 132. 1998. Volkswagen introduces the VW E188 pump-dues engine, 1.9 TDI, with Bosch-developed electronically controlled unit injectors. 124. 1999. Daimler Chrysler presents the first common rail 3-cylinder diesel engine used in a passenger car, the Smart City Coupe. 82. 2000s. Audi R10 TDI, 2006 24 Hours of Le Mans winner. 2000. Peugeot introduces the diesel particulate filter for passenger cars. 82. 124. 2002. Piezoelectric injector technology by Siemens. 133. 2003. Piezoelectric injector technology by Bosch. 134, and Delphi. 135. 2004. BMW introduces dual-stage turbocharging with the BMW M57 engine. 124. 2006. The world's most powerful diesel engine, Fiat Siler RT Flex 96C, is produced. It is rated 80,080 kW. 136. 2006. Audi R10 TDI, equipped with a 5.5-litre V12 TD engine, rated 476 kilowatts, wins the 2006 24 Hours of Le Mans. 82. 2006. Daimler Chrysler launches the first series production passenger car engine with selective catalytic reduction exhaust gas treatment, the Mercedes-Benz OM642. It is fully complying with the Tier 2 BIN 8 emission standard. 124. 2008. Volkswagen introduces the LNT catalyst for passenger car diesel engines with the VW 2.0 TDI engine. 124. 2008. Volkswagen starts series production of the biggest passenger car diesel engine, the Audi 6-litre V12 TDI. 124. 2008. Subaru introduces the first horizontally opposed diesel engine to be fitted to a passenger car. It is a 2-litre common rail engine, rated 110 kW. 137. 2010s. 2010. Mitsubishi developed and started mass production of its 4N13 1.8L i4. The world's first passenger car diesel engine that features a variable valve timing system. 128. 2012. BMW introduces dual-stage turbocharging with 3 turbochargers for the BMW N57 engine. 124. 2015. Common rail systems working with pressures of 2500 bar launched. 82. 2015. In the Volkswagen emissions scandal, the US EPA issued a notice of violation of the Clean Air Act to Volkswagen Group after it was found that Volkswagen had intentionally programmed turbocharged direct injection (TDI) diesel engines to activate certain emissions controls only during laboratory emissions testing. 138, 139, 140, 141. Operating principle. Overview. The characteristics of a diesel engine are 142. Use of compression ignition, instead of an ignition apparatus such as a spark plug. Internal mixture formation. In diesel engines, the mixture of air and fuel is only formed inside the combustion chamber. Quality torque control. The amount of torque a diesel engine produces is not controlled by throttling the intake air, unlike a traditional spark ignition petrol engine, where the airflow is reduced in order to regulate the torque output. Instead, the volume of air entering the engine is maximized at all times, and the torque output is regulated solely by controlling the amount of injected fuel. High air-fuel ratio. Diesel engines run at global air-fuel ratios significantly leaner than the stoichiometric ratio. Diffusion flame. At combustion, oxygen first has to diffuse into the flame, rather than having oxygen and fuel already mixed before combustion, which would result in a premixed flame. Heterogeneous air-fuel mixture. In diesel engines, there is no even dispersion of fuel and air inside the cylinder. That is because the combustion process begins at the end of the injection phase, before a homogeneous mixture of air and fuel can be formed. Preference for the fuel to have a high ignition performance, cetane number, rather than a high knocking resistance, octane rating, that is preferred for petrol engines. Thermodynamic cycle. The diesel internal combustion engine differs from the gasoline-powered Otto cycle by using highly compressed hot air to ignite the fuel rather than using a spark plug. Compression ignition rather than spark ignition. In the diesel engine, only air is initially introduced into the combustion chamber. The air is then compressed with a compression ratio typically between 15:1 and 23:1. This high compression causes the temperature of air to rise. At about the top of the compression stroke, fuel is injected directly into the compressed air in. Diesel engine model. Left side diesel engine model, right side combustion chamber. This may be into a, typically toroidal, void in the top of the piston or a pre-chamber depending upon the design of the engine. The fuel injector ensures that the fuel is broken down into small droplets, and that the fuel is distributed evenly. The heat of the compressed air vaporizes fuel from the surface of the droplets. The vapor is then ignited by the heat from the compressed air in the combustion chamber. The droplets continue to vaporize from their surfaces and burn, getting smaller until all the fuel in the droplets has been burnt. Combustion occurs at a substantially constant pressure during the initial part of the power stroke. The start of vaporization causes a delay before ignition and the characteristic diesel knocking sound as the vapor reaches ignition temperature and causes an abrupt increase in pressure above the piston, not shown on the PV indicator diagram. When combustion is complete, the combustion gases expand as the piston descends further. The high pressure in the cylinder drives the piston downward, supplying power to the crankshaft. As well as the high level of compression allowing combustion to take place without a separate ignition system. A high compression ratio greatly increases the engine's efficiency. Increasing the compression ratio in a spark ignition engine where fuel and air are mixed before entry to the cylinder is limited by the need to prevent pre-ignition. which would cause engine damage. Since only air is compressed in a diesel engine, and fuel is not introduced into the cylinder until shortly before